Good day, everyone. Um, we're going to have the second to the last topic, which is probably proof by cases. Yung cases, proof by cases, ito yung cases na may case 1, case 2, case 3, case 4, which is probably different levels of case and how it is going to prove. So we could go on and on and on about different proof styles. We haven't even mentioned induction or combinatorial proofs. So si induction, the other term niya is combinatorial proof. Combinatorial proofs pala. Combinatorial proofs. Okay? So yan yung um, other term ni induction. But instead, we will end with one final useful technique, which is probably proof by cases. But I actually have listed mathematical induction in the last video para kasi mahaba-haba siya. Okay? So, it's some thing and sting and this thing and this thing. So, probably it is very large promotions. Anyway, okay, there's probably proof by cases. But in this section, we're going to stop na lang for the proof by cases para ma-understand ko yung how it is induction be um, very well. Kasi different techniques kasi. May K plus 1, ganyan. So, it seems like um, very tricky. But I will show you how um, to prove using induction. Okay? Kasi different styles ng module tsaka yung probably yung more ordinary proof by induction. So I will teach you that very soon. Okay. So this idea to prove that P is true by proving that Q implies P and not Q implies P for some statement Q. So no matter what, whether or not Q is true, we know that P is true. In fact, we could generalize this. Suppose we want to prove P. We know that at least one of the statements are true. Okay? If we can show that Q sub 1 implies P and Q sub 2 implies P, and so on all the way to nth term implies P that we could put P. The key thing is that we want to be sure that one of our cases must be true no matter what. So isa sa mga cases, dapat lang isa sa mga cases prove na yung statement is not equal to this statement or this statement equal to this statement by cases. So, how are we going to prove that? Okay, for the first example, for any integer n, the number n cubed minus n is even. So we want to prove by these two cases, an odd integer and even integer. So how are we going to do that? Okay, so we have two cases here. Now, it seems that n cubed minus n is even. So we're going to show that this state, um, this variable or expression is probably even. So there are two cases. Okay, so we have case one. Okay, sulat ko na lang um, para sure. Okay, so proof by cases. Okay, so okay, so proof by cases. We have case one. Um, let's say even integer. Okay, let n equal to 2k. So it seems that we're going to locate an even number kasi even number si 2k, di ba? Even siya. So we're going to prove that this statement is even. So we have n cubed minus n. So we have 2k k cubed minus 2k. Then we have 8k cubed minus 2k. Therefore, we're going to factor out the number, which is probably 2. Then we have 4k cubed minus k. Then we let p equal to 4k cubed minus k. So therefore, we have 2. So it seems that this um, this expression using the even definition is probably uneven. So, okay. So, makikita natin dito. Okay? So, kita-kita. And the other case is for somehow an odd. So, let n be equal to 2k plus 1. So, if we're going to let this as 2k plus 1, so we have n cubed minus n equal to 2k plus 3 plus 1 cube plus minus 2k plus 1. We're going to use the trinomial. So n plus, let's say we have a plus b cube. So we have a cube plus 3a squared b plus 3ab squared plus b squared. Or you can use the coefficients 1, 3, 3, 1. So if all of you are STEM, no, if all of you are STEM, you can use the binomial theorem, no, or the Pascal's triangle to improvise the statement. So it seems that 1, 2, 3, 1 is the coefficient of this one. So we have um, okay. So our A is 2k, and we will let A as 2k and we let 1 as B. So we have 2k cubed plus 3 times 2k squared times 1 plus 3 times 2k times 1 squared plus 1 cubed minus 2k minus 1. So we have 8k cubed plus 3 times 4k squared plus 6k plus 1 minus 2k minus 1. So we directly cancel this. So we have 8k cubed plus 12k squared. Then combine 6k and negative 2k by minus plus 4k. Then um, common factor, which is probably 2. We have 4k cubed plus 6k squared plus 2k. Then we let p equal to 4k cubed plus 6k squared plus 2k as probably in the simplest form 2. So therefore, we prove that n cubed, the expression n cubed minus n is probably an even integer. Kasi di ba? So even sila. Gets? Okay. So thus, it is even. And that's it all. And for the last one, okay, I will stop presenting first. Then probably a window and don't proof by cases. Okay. Okay. Oops. Sorry. Sorry. It seems, yeah. Ganyan talaga yan pag 12 p.m. na. So, let's see. Okay, for the second one, is we're going to, okay, we have the claim if n is an integer, then 2n squared plus n plus 1 is not divisible by 3. So we're going to prove that 2n squared plus n plus 1 is not divisible by 3. So, okay, we're going to assume n an integer. Then we recall that when an integer is divided by 3, then 0, 1, or 2 are possible remainders sa tatlong cases. This suggests that n is equal to 3a plus 0 or 3a, then 3a plus 1, and 3a plus 2 for some integer a. Then we proceed by proof by cases. So, okay, for the first case, we have assume n is divided by 3 with remainder 0 such that n is equal to 3 plus 0 for some integer a. Then we have 2n squared plus n plus 1. So we're going to substitute 3a plus 0 or 3a to the equation 2n squared plus n plus 1. As such, this would be the remainder probably. Now, if we divide both sides, if we divide this by 3, so we have 2 times 3a plus 0 squared plus 3a plus 0 plus 1. So we have, okay, so, uh, uh, so how we're going to do this? Okay, so it seems that for all this statement, we have to prove that. So, okay, so for the case 1, okay, we let n equal to 3a. 3a na lang. Kasi same naman sila. So we have 2n squared plus n plus 1. So we have 2 times 3a squared plus 3a plus 1. Okay, ganito. Bakit may parenthesis siya? It's because my parenthesis is because you are going to substitute pa. Okay? Substitute mo pa. Then, we're going to, or pwede naman mo nang mawala yung parenthesis when it comes to different deep conclusion siya or probably yung solution. So, sa'yo na, it's all yours. Not all yours, but it's your liberty to, to solve this. So, we have 2 times 9a squared plus 3a plus 1. So, nawala na yung parenthesis. Then we have 18a squared plus 3a plus 1. Okay? So, now, in this section, we're going to regroup this according to the variable. So we have 18a squared, 18a squared plus 3a plus 1. Then factor out 3 kasi divisible by 3. So we have 6a squared plus a plus 1. Then we let p equal to 6a squared plus a. So we have 3p plus 1. So therefore, it is not divisible by 3. So, proven siya. Okay? Therefore, it is not divisible by 3. Okay. How about the second case? So, case 2, eh, um, let n, or probably n equal to 3a plus 1. Okay. So, 3 plus 1. So, how we're going to do that? So, same pa rin. No? So, 2n squared plus n plus 1. So, we have 3, 2 multiplied by 3a plus 1 squared plus 3a plus 1 plus 1. So we have 2 times 9a squared plus 6a plus 1 plus 3a plus 1 plus 1. So we have 18a squared plus 12a plus 2 plus 3a plus 2. Then we have 18a squared plus 12a plus, ano, plus 15a plus 4. Sa akin is very different masyado but it's the same pa rin. Then, we have let 4 equal to 3 plus 1 kasi divisible by 2 siya. So we have 18a squared plus 15a plus 3 plus 1. Okay? Then we have, um, what do you call this? Uh, regroup this 18a squared plus 15a plus 3 plus 1. Then we have factor out 3, so we have 6a squared plus 5a plus 1 plus 1. Then we let k, okay, pwede siya any variable be equal to 6a squared plus 5a plus 1. Therefore, in conclusion, we have 3k plus 1. So it is not divisible by. Okay, sa akin is different kasi parang diretso lang. So sa akin is 18a squared plus 3 plus 4. Then I regroup it as 18a squared plus 15a plus 4. Then we have 3 times 6a squared plus 5a plus 4. So it is the same but different techniques. So ginanito akin na. Parang ganito akin. So dito, diba? So I can regroup this na para mas madali plus 4. Then we have 3 factor out 3, so we have 6a squared plus 5a plus 4. So we have 3. Okay, k let's say let k equal to 6a squared plus 5a. So we have 3k plus 4. So it seems that we have different solutions but different techniques. But according this one, we have the same um, techniques. But we will have to follow this step para hindi malito. Okay? So I'll just probably write this all along. Okay. So yan. So same sila pero yun na nga not divisible by 2 pala. Then okay, I know. So then the last one would be let k for the case 3 k n is equal to 3a plus 2. It seems that this would be the last one. So same pa rin tayo. So we have 2n squared plus n plus 1. So we have 2 times 3a plus 2 squared plus 3a plus 2 plus 1. So we have 2 times, what do you call this? Tama ba? Okay, 9a squared plus 12a plus 4 plus 3a plus 3. So we have 2 times 9a squared plus, that would be 18a squared plus 24a plus 6 time plus 8 plus 3a plus 3. Then we have 18a squared plus 27a plus 11. Then we let 11 equal to 9 plus 2. So we have 18a squared plus 27a plus 9 plus 2. Then we have to regroup this, as the factor of 9 or factor of 3. So 18 squared, 18a squared plus 27a plus 9 plus 2. Then factor out 3. So we have 6a squared plus 9a plus 3 plus 2. Then we have to let any letter. So s is equal to 6a squared plus 9a plus 3. So we have 3s plus 2. So therefore, it is not divisible by 3. So, sa tatlong ito, there is no divisible by 3. But as it seems, no, As it seems, yun pa rin. So, we have proved the claim. So, ito yung claim. So, we proved that 2n squared plus n plus 1 is not divisible. So, yeah. Okay, so that would be the end of our session. And thank you so much for watching. And I will see you for the mathematical induction first. That's all, and good morning.